that a lot of the misconceptions around what is easy or hard in AI, when it comes to thinking that it's easy, it tends to be around misunderstanding the huge lift that it takes to get high quality representative data. And then the misunderstanding how huge a lift it is to get a product in production that is scalable. That also has a lot of corner cases in mind.
All right, everyone. Welcome to another episode of the TWIML AI podcast. I am your host, Sam Charrington. Today, I'm joined by Patricia Thaine. Patricia is co-founder and CEO of Private AI. Before we get going, be sure to take a moment to hit that subscribe button wherever you're listening to today's show. Patricia, welcome to the podcast.
Thanks so much, Sam. Great to be here.
I'm looking forward to digging into our conversation. We'll be talking about some really interesting things you're doing with regard to AI and privacy and more. To get us started, I'd love to have you share a little bit about your background and how you came to start Private AI.
Yeah, sounds great. Personally, my background is in doing research in privacy preserving natural language processing. Specifically, it was originally focused on homomorphic encryption. So that lets you compute on encrypted data. And co-founded the first version of Private AI on that topic. I have a academic hammer. Let's go find all the nails. Didn't work out. Turns out that's a very bad way of problem solving. And then started the second version of Private AI, really with the focus of building a privacy layer that's built for developers that can actually help them comply with data protection regulations.
And now there are, I think, a couple of ways for us to dig into this topic. The first, I think, is to dig into like what private AI is doing for AI developers and how those capabilities are expressed, and then also like how you're using ML and AI to do all of those things. But let's start with the use cases and what you're trying to enable.
Absolutely. So the core technology is understanding what's in your data. What kind of personal information you have, protected health information, payment card industry information, confidential information. All of these can play a really big role in whether or not you can end up getting data for your AI projects, whether or not you're going to be able to use third party tools, what exactly happens with regards to the output of the training data when it comes to sensitive information being displayed to your users or employees or otherwise. And so really what the product does is identifies this personal information and is able to redact whatever it is that you don't need. And that's really the concept of data minimization, which is core to a lot of data protection regulations.
Got it. Got it. Minimization from the perspective of not having data that is not necessary in the process.
Exactly.
And it sounded like we're talking about data that comes into contact with a system in three different places, maybe even more, but certainly input and output, and maybe storage. And can you kind of talk about data flows and the way you see them?
Absolutely. So if you look at large language models in particular, for example, you're going to be sending data maybe to a third party, in which case, whatever information you're sending, you're losing control of when you're sending it external to your organization or to your own laptop. And so it's really important to think about what kind of information you're sending through. What can you remove? And then once that information is removed, it can very often be reintegrated into the resulting output of the model. And so you can still have a fairly seamless interaction with the model without that risk of sending that data externally. And then other aspects of it are even if you have a model internally within your own private environment, there are a few things to be concerned about. One, are you collecting data that you shouldn't be? Because whatever data that you do collect puts you at higher and higher risk of a more significant data breach down the line. That's part of the interesting part about data minimization. You keep what you need. It's you don't keep what you don't need, meaning that you strip out that risk from your data in the very likely chance that at some point there will be a data breach. And then there are other aspects to it with regards to training. When it comes to training models, I think this community probably is aware that that data can be quote unquote memorized by the model.
And leaked
How
out.
yeah, and as a result, leaked out. And there's lots of research showing this. There initially for character language models, then for GPT-2, and then there are more and more coming out around exactly the risks around training or fine tuning on personal and confidential data.
And we've got some episodes we can link to in the show notes about that topic.
Perfect. Oh yeah, I saw that you interviewed Professor Carlini. That's
Mhm.
yeah, great person to talk to about that. Um, then there's also the risk of having personal and confidential data in the contextual data that you're using to create embeddings for RAG, for example. And that's the one where a lot of people actually don't think about. The assumption is that if it's an embedding, it's
It's
generalized
kind
enough
of
that
opaque, right?
yeah,
Yeah.
exactly. But that is completely untrue. And there's research showing how if you have, for example, word embeddings that are created through from healthcare data, the names and first names end up closer in distance to last names, and disease that somebody had ends up closer in distance to the relevant name.
Mm.
And so, even just if you can't inverse the embedding,
Does that mean that is subject to leakage or it's subject to attack? Like I can get attacking that, but
yeah,
kind of passive leakage seems more difficult to less likely, I guess.
no, it's subject to both. It's subject to both.
Really?
But I like that you're bringing that up because I was doing a deep dive around inversion attacks of embeddings. Right, there are some that are showing that when you invert an embedding, even a dense embedding, you can get up to 92% of the original context. So that's an attack,
What?
right?
Okay.
That's an attack. However, what is more likely is that you are going to be leaking that information to as part of the output of the model. So, if you, for example, have embeddings that discuss that are contain information about people's salaries, for example,
Mhm.
that can get leaked out in one of the examples for a data leak for one of these LLMs was finding out the salary of a CTO at a company. Um, the This can happen with embeddings just as much as with fine tuning.
Interesting. Interesting. And was the CTO salary example, that was an embedding leakage
I
or
don't know.
okay.
I
Uh,
don't know if
can
that's
you
public info.
can you talk through an example of like how an embedding leaking data would work? I guess I'm imagining a scenario like a scenario with regard to a particular condition, and somehow the name that it uses as the example is a real person's name. Is it like that kind of thing,
Yeah,
or
so these embeddings can be more than just word embeddings, right? They could be representative of paragraphs of documents. They could be chunks that are basically easy to search. And then when you send in your query through your large language model, it's going to go through an embedding model, look through your database of embedding, see what's closer to the query, and then produce an output with that information. And so if that query is asking for something sensitive, that sensitive piece of information could be leaked. And it could even be leaked accidentally if even if you're not asking for something particularly sensitive, but it is relevant to the context of the question.
but then we need to distinguish between sensitive information being in the corpus of chunks that the embeddings are referring to and leaking information from the embeddings themselves.
So we need to distinguish between the leak if you have access to the embeddings directly, and how you can pull out information from there. Whether or not it's an inversion attack, whether you're doing a distance measurements and you have or similar, and you have to distinguish that from uh, output or risk with output from models that are using a database of embeddings to create responses.
Does the risk require that the sensitive information still be in the data, or can just the fact that the sensitive information was used to produce the embeddings, even though the database has been scrubbed, cause problems?
Mhm. So if the sensitive information was used to produce the embeddings, the chances are that there's sensitive information left over in the embeddings themselves that
Yeah,
could
yeah,
be output. And so that's why the recommendation there is de-identifying data before you create embeddings, or understanding what data you have in the first place to not include that personal information, period, and just stripping out that entire piece. It depends if you need the context or not around that personal information.
right.
And the interesting part is that a lot of the times you don't need the personal information to get value from a lot of NLP applications. If you think topic modeling, sentiment analysis, uh, and many other ones. The sensitive information is generally superfluous, unless you're doing something very explicit in HR or need specific customer information for things like your master data management system. You're not going to. You often don't need that personal information, and in addition to that, um, that personal information can lead to more bias in the responses. And so that's something else to watch out for. More and more research is coming out about how things like physical attribute or the country that you're from or the political affiliation, et cetera, that can all lead to biased responses from the model. And so by removing that, that removes the or reduces the risk of having biased responses.
Got it. Got it. Got it. So that kind of brings us full circle to how folks might use private AI. So one is you are interacting with third party LLM and you've got sensitive information that you don't want to be exposed to that LLM. And so private AI would sit between your system and the LLM and kind of cleanse that data as it's passing through. And
Correct.
then there's another part that is about if you're training, doing fine tuning or training embeddings or some aspect of using data to build a model, then you can also cleanse that data kind of in. Is it like in place or is it as part of the training loop that you're working with that data?
It's an API, so it runs in your environment. You send a post request through, and then out comes the redacted data and the list of personal information and sensitive data that was found. And so you could put it anywhere in your software pipeline. That makes sense.
Got it. And um are you typically doing it request by request, or like are there batch or bulk APIs?
There's a batch mode and also a streaming mode as well.
It sounds like a foundational part of what you're doing has to be kind of entity recognition, identification in this data, because the user's not expected to tell you specifically um, the entities that are, well, what information does the user need to provide is maybe a better place to start.
Yeah, the user can provide the so we provide a list of entities that they can identify. And they could either choose to, by default, remove all of them. They could choose which ones to remove if they don't want all of them, or they could choose based on regulation that they're trying to comply with. So if it's HIPAA or if it's GDPR, CPRA, you could choose which one you want, and then it'll auto select which entities make most sense for that regulation.
Thinking about entity recognition in general, like that's been a problem for a long time. And um, on the one hand, because it's been around for a while and there are lots of different solutions, I think it's tempting to think that it's like a solved problem. On the other hand, if you have any experience trying to get LLMs or even traditional tools to do this, it is very hard. Talk a little bit about your experience with the entity recognition part.
Yeah, I think that a lot of the misconceptions around what is easy or hard in AI, when it comes to thinking that it's easy, it tends to be around misunderstanding the huge lift that it takes to get high quality representative data. And then the misunderstanding how huge a lift it is to get a product in production that is scalable. That also has a lot of corner cases in mind. And part of the part of the problems that you have to deal with when building a named entity recognition system are you're going to deal with optical character recognition errors. You're going to deal with automatic speech recognition errors, depending on, of course, your use case. But if you're dealing with a lot of data, like many of these large organizations are, uh, the different types of contexts is huge, and then the different languages that it needs to apply to as well. So, and then all of the different entity types that you need to uh, be able to perform well enough on for it to be good enough to comply with data protection regulations. So it's a huge balance between speed, accuracy, and then multimodality in addition to that, because it needs to generally deal with results from files and, of course, text, transcripts, chat logs, but audio as well. And if you put all of that together, that's a giant problem space to deal with.
Mhm.
So it's named entity recognition itself is an important piece of the puzzle. Everything else is also a huge lift. For the named entity recognition lift, if we double click on that, you have to think about the 50 plus entity types that you often need to recognize for for some of these regulations, multiplied by the number of languages that you need to function on, and you need to do that in a way that's also speedy, right? So we've created data pipelines that are very efficient with regards to adding new entity types. We've created data pipelines that are efficient with regards to creating synthetic data to add to our current data, because there's no real personal information that you could go out and capture in the wild. You have to basically either beg customers for data, or you have to create your own. And then finding out what kind of data you need to add to the model in order to make it more efficient or more effective without uh, while limiting the decrease in efficiency in your data process with the more data that you add.
Is the customer training the entity recognition model, like, or it's supposed to be zero shot with regard to the customer data?
Yeah, absolutely no training by the customer. And for PII in particular, and here's why. Um, it takes a lot of training to know how to annotate properly. If you introduce errors in the annotation process, that can have bad effects on the models. Then we can't help you debug the model because we don't know what kind of data you put in there. Um, the In addition to that, the basically we won't be able to provide the same model of that's consistent for the kind of corner cases that you have that might be relevant to other customers as well.
Meaning if a customer is fine tuning, what you're doing, then that it impacts repeatability across customers. And then, are you, as part of the service, like, are you making some type of guarantees to the customer, or anything like that?
We do have a warranty that's optional that folks can buy, and that's provided by Armilla AI, and it has a certain accuracy threshold that is guaranteed that we reach. If not, your contract money is returned to you, and we have a certain time period in which to fix anything that falls below that threshold.
And so your ability to honor kind of warranties or like that is going to be impacted if you're customizing the model for each customer.
Yeah. However, we do deal with extremely sensitive information, often things like credit card numbers for PCI compliance, or healthcare information where folks do not want to have to go into the healthcare data and look around to see whether anything was missed. And so our the stakes are pretty high when it comes to accuracy.
Can you talk a little bit about, like, how about generalizability and, like, how you've built the system to be able to deal with generalized data? Um, without training or tuning to specific customer use cases. I would imagine there's a fair amount of, even though we're limiting ourselves to entities, I would imagine there's a fair amount of variability in the types of files and documents, and that could be problematic.
Correct. Lots of data is the answer to
Okay.
that. Lots of data collected over the years, where oftentimes it's our customers saying, "Hey, you missed this stuff, fix it," and they send us a chunk of data, and then we'll add synthetic data to that, and do a lot of rounds of testing. Um, but yeah, it's a big lift to be able to have a generalizable model like that.
You mentioned multilingual as well. Is that also solved with more data and the models deal with it on their own, or are there specific challenges and things that you have to do in order to support multilingual?
There are specific challenges, and oftentimes it could be things like when you have multilingual data, conversations, for example, so code switching. That can be fairly tricky to deal with. The Also the ability to detect what kind of language is being used to be able to provide the best model. That's something that we put in place as well. So a language detection system. Um, the ability to also, based on the language detection system, provide different labels in the appropriate languages is also something that we've worked on. Um, and so there are more data, definitely, but also how do specific models deal with logographic languages, Chinese characters, for example, versus um, uh, alphabets like English, and being able to find models that are suitable for each of these, in addition to finding optical character recognition models that are suitable for each of these, and to training them with the right data is very tricky.
And you've mentioned OCR a couple of times. Is the presumption that your customers are not responsible for the OCR themselves? They're giving you whatever their raw data is and PDFs and scans and all that, and you have to deal with it for them.
It depends on the customer, but oftentimes, yeah, we have to deal with it.
And OCR is another one of those things that is like, oh, that's a solved problem. But
And it's not. Mainly again because of data complexity, because you've got documents within documents or images embedded in documents, and being able to it's not about just surface level comprehension, right? It's not just a summary that you're providing. It's This is really detailed work that's being done, and that's
meaning you need to be able to find the name in the chart in the section in the on a page in an image, basically.
exactly, yeah. And when folks say, "Oh, I could just do that with a large language model," it's really not taking into consideration the amount of lift it actually takes for the more detailed work at a large scale, uh, in actual production when you're handling so many different variables at once. So large language models are out of the box very good for things like summarization, for giving you ideas, stuff like that. But when it comes to really detailed work, the data is still incredibly important.
And so, as opposed to large language models, you're using more traditional approaches to these various problems, entity recognition and OCR, and are, that question, but also like, are you using off the shelf, open source or commercial things, or if you rolled your own for most of the underlying models? Like, how do you think about your model supply chain?
So when we think about it in the sense of what our customers really need, and they're dealing with massive volumes of data. And so large language models tend to be too slow for them. And the amount of additional accuracy that one might get with a large language model with where we're trained on the data that we have and adapted for their tasks is often not worth the speed and cost increase for the customers. And so we spend a lot of time focusing on um, making the models as accurate as possible in a smaller package.
And so there are multiple ways you can do that. You can, start from a traditional base and kind of build up from there, or you can like take a large language model and distill it down to a smaller language model. Is there a general direction that you prefer for these kinds of tasks?
It's a continuous experimentation process. We're always trying different things to see what uh, how much juice we can squeeze out of things.
You mentioned synthetic data a bit. Can you dig into that a little bit more and some of the ways you're thinking about that?
I can a little bit. A lot of synthetic data is helpful when you don't have enough data for a particular problem. I think one thing I want to point out there is mm, some folks might think that synthetic data is the right way to go for training their models, which might be true, and it worked for us. And the reason that it worked for us is because we also have a good balance of real world data uh, in addition to the synthetic data, and we've informed that synthetic data with the real world coordinate cases. Um, when it comes to fully synthetic data, uh, the hesitation there is that it if you're able to create fully synthetic data for a problem, that problem might, for in some cases, depending on the problem that you're trying to solve, that problem might already be solved because you were able to create that data. Um, In other cases, you might lose context, where you might need things like conversation flow information, or did a particular customer service agent need training in a particular case, and medical information that's related to one another, to different parts of uh, a different time, a full timeline of a patient, for example. And so the the type of synthetic data that we use is usable because we have access to high quality original data, and we also have a very specific task where this works out well for it.
And are you like at what level are you primarily using synthetic data in the process of training the entity recognizers? Or are there other parts of the system where synthetic data comes in handy for you?
We also generate synthetic personal information as part of an option for the output. And that's one of the interesting pieces where if you want to keep things like conversational flow or topic modeling and things like that, you still can because the majority of the context is still there.
Meaning, as opposed to masking, you can generate synthetic data that takes the place of the original tokens.
Yeah.
Interesting. Okay.
Yeah. And so very similar to masking, you could still keep the context of the data.
We've talked a little bit about OCR and how you're using that. That's one example of multimodality. Can you talk about other ways that you're using and incorporating multimodal data?
Yeah. So we also do provide the ability to redact information, generally for PCI compliance, from audio recordings. And so you could bleep out the personal information from the audio recordings themselves.
Meaning, I've got a call center and I'm recording for quality assurance, and people are talking about they're incorporating personal PII into those conversations, and you want to redact it before you store it, for example.
Correct. That's right. And that's really important for PCI DSS compliance, where you do need to remove things like credit card numbers and account numbers. And the way that we do that is very much by, where we bleep out the PII. One thing I will point out is that there is some research on anonymizing the voice within a recording. And that's interesting because if you anonymize information, it falls outside of certain data protection regulations like the GDPR. And for those listeners who don't know, the GDPR is the General Data Protection Regulation in the EU, and it basically covers what you're allowed to do with personally identifiable information and and consent and all that jazz. So if you anonymize data, which basically means there's a very very low risk of re-identifying the individual, then you don't have to comply with that regulation because you're no longer dealing with personal data. Um,
But anonymizing the voice doesn't remove responsibility to anonymize PII that's
it
mentioned
does not.
in the, yeah.
That's correct. And so the voice is a biometric identifier. And you can, I'd say at your own risk, modify the voice and perhaps call it anonymous, but there's not enough research out there, in my opinion, to say that a voice modification cannot be reversed. And and so there are certain assumptions you might have to make with regards to whether or not you can consider an audio recording actually anonymized. But data minimization is not just about anonymization; it's about limiting the risk of the data. And in situations like removing credit card numbers, you're reducing the risk of fraud, for example. And if there's a data leak, reducing the risk of how much information is going to be part of that data leak.
And are you doing this on stored audio, or do you have the ability to do it real time?
It could be both. We are not an ASR
That sounds
company.
a lot harder.
Yeah, yeah, it is hard. It is hard, but we are not an ASR company, to be clear. So we can do it on audio, but if anybody needs something that's more specialized, like things like diarization of audio or uh, things that, yeah, if you need actual control of what's going to happen to your audio aside from de-identification, there are lots of good companies out there like uh, Deepgram, which I saw that you interviewed, Assembly, and Twilio, and so on, who can do a great job at that.
You have an audio stream coming from your call center. People are mentioning PII and credit card numbers and the like on your audio stream. You can real time redact certain types of PII as it's happening. Is text being used as an intermediary, or is it happening real time on on voice?
Yeah, text is being used as an intermediary. To If it were to happen real time on voice, you'd be talking about probably keyword detection. And then you have to train a model specifically on keywords. That's just a very large search space of keywords to be looking for.
Got it. Got it. Got it.
Yeah, I
So
mean, you could train it for digits, for example, and probably be okay, but that's a big problem.
so now I'm thinking about even with text as an intermediary, you're either doing like word level resolution where each word has a time associated with it, but then I'm imagining there's certain types of well, even like a string of credit card numbers, like you have to zoom out beyond individual numbers to know what's happening there, or you can look at like complete utterances, but then you still have to figure out like how to align the credit card number that's in the middle of a phrase um, with the audio. Like, how do you deal with that? Is that a big deal for doing this, and how do you deal with that?
No, it definitely is, and the reason is because of disfluencies in speech, right? So somebody might say, "My credit card number is 59. Oops, I dropped my card. Sorry, it's 32. 592. Oh no, that was a 2, not a 4."
Yeah, I wasn't even thinking about that. That would make it even a lot harder. I was just thinking about
That's
having been looking at you know looking at some transcription ASR data recently
Mhm.
and the different levels that you can use it. Like it,
Yeah. No, it's definitely tricky. So the more context, the better. Definitely. Uh, the the cleaner the transcript, the better, as well. And if it's only one language, it's also easier. But the world isn't perfect, and none of these things really apply most of the time. Maybe the unilingual aspect, but even then.
like what I guess I'm trying to get at some kind of practical detail there in terms of either models or things that people should be thinking about in terms of the data, or if someone's encountering problems like this, what should they be thinking about, or what have you learned about tackling it?
Real world examples are extremely valuable, and you might have all sorts of. So that's the limitation of fully synthetic data. Um, what you expect to encounter is very different from what you might encounter in the real world, and oftentimes you don't. It's very hard to get access to that real world data because of personal information. And so, one thing you can do is use our synthetic PII model to generate just the synthetic personal information and get access to the rest of the data, which might be relevant for your more minute use cases.
Meaning just inject synthetic PII into random places and conversations?
Instead of the actual PII, because oftentimes you can't get access to data because of the privacy concerns.
Meaning if you're building models and part of the reason why you can't build strong enough models is because you can't get the data because of the PII concerns, you can use a tool like yours to mask the PII or make a synthetic version of it with synthetic PII, and then um, convince somebody to give you their data based on that.
Correct. Yes, we have
Okay.
customers who use us for that purpose.
Okay.
Mhm.
Okay. Got it.
And there will be some who have contractual agreements for that with their customers, where they promise to anonymize or reduce the PII and the data in order to be able to train their models with it. And that's becoming more and more important as people realize the actual harms of training models with sensitive information.
Also on the multimodal front, I think when we spoke previously, you mentioned something about like logo detection in documents was a challenge that you ran up against at one point.
Yeah, yeah. So we have more and more requests for confidential information detection because also of large language models. And so we've built out a solution that deals with that. Also, dealing in the confidential information detection piece, that one we do handle with customers to adapt to their particular confidential information, because that changes even on a daily basis for some. But logos is actually something that comes up as confidential information. So if you have, for example, a customer presentation and you want to train a model or send that through to a model, and you don't want to send that customer logo through, that's something that we can blur out so that you don't have to deal with that piece of information. But that's another piece. Think about building a privacy solution. It's so many things that come up that you don't expect, that you need to collect knowledge about year after year to keep improving the product. So it's not something that you could just build out of a box with a named entity recognition model that recognizes 5 entities. It's a real drag to actually figure out what's what.
How do you maintain your product as a coherent system as opposed to a patchwork of, kind of individual things to address individual issues? I'm imagining that becomes a challenge just in terms of, manageability of the system and like, code manageability. Like, is there a particular approach that you found useful for that?
Well, one, having great architects and engineers, but would highly recommend if you can afford them. But two, um, the there can definitely be product creep or feature creep, and we'll have folks requesting entity types that don't have to do with privacy, and if we can't fit it into the framework of whether or not it has to do with privacy or confidentiality, then it's not something we really consider doing. We do have many folks using us for named entity recognition because of how highly accurate our system is. And that's where that creep can come in those requests. So it's really about keeping it focused. Otherwise, it I think people already sometimes have a hard time figuring out what we can help them with, thinking we just do de-identification when we can also do this detection and incorporation into their risk pipelines and their data catalogs and MDM systems and so on. Um, so not having that go beyond the realm of our goal is privacy and confidentiality, and making sure that it's as important and as good as cybersecurity processes.
Can you talk a little bit more about the integration with data catalogs and MDM systems? Is it just that you have masked the data before it gets put into those systems, or are we talking about something different?
Different. In this case, it's using that named entity recognition aspect of it to create metadata that goes into those systems. So while you're de-identifying data to go into your models, for example, you're cataloging that data and putting it into your data catalog so that you could go back to it and see what the risks were or are of specific data sources. And you don't have to go and redo the work every time.
So while you're de-identifying, what is the data that you're putting into your data catalog? The entities that you pulled that you identified, or the de-identified
Yeah,
snippets, or
entities that you
okay.
yeah, that are identified, along with the data source, as an example. There can be other aspects to it as well, depending on what aspects of data protection regulations you want to comply with, and how you want to build out that internal privacy pipeline. But yeah, that's very much it. So if you think about it, the there's a really robust system right now in place within organizations to deal with compliance for structured data. And 80 to 90% of the data they have is unstructured. There is no real robust system for folks to deal with that at the moment. And with our technology, uh, what people can do is build out that system with that single API to pull that data from the unstructured side of things into their pre-existing data catalog and MDM system. And that means that suddenly you've got that robust data management system covering all your data, not just 10 to 20% of it. And one really good place to start is if you're already dealing with that data for building up your large language models, you're looking at the risk of the data, you might as well use that information to start updating your internal systems.
You mentioned earlier a bit about how the kind of the connection between privacy and ethical, responsible AI, and how the personal information leaks or can leak into models and cause downstream biases. Can you elaborate on that a little bit? Sounds like that comes from research that you've come across.
Yeah. So I used to, when I had a little bit more time, co-organize this workshop at various computational linguistics conferences. The last one was at ACL. And in this last one, there were a couple of papers talking about how the input to a model can affect the output based on bias. And one of them was about physical attributes and how that can affect the if those physical attributes are about disabilities, that can affect the output of the model. And when we first came out with private GPT, we were also looking at what kind of biases can uh, the model have depending on the PII. One of the experiments we ran, which has been since corrected, was if you write out my friend is British, and he's in prison. What are some of the reasons that he might be in prison? You get very different results from my friend is from Somalia, and is in prison. What are the reasons my friend might be in prison? And if you just say my friend is from country one, what are some of the reasons he might be in prison? You get much more unbiased results as an output. And so, what this is showing is, the inherent bias that is in the internet is being showcased in the output of these large language models. We we can try to minimize that by minimizing at input the pieces that might lead to that bias.
Got it. So as opposed to trying to mitigate it via prompting techniques or various other things, if the input data is kind of has these inherent identifiers, whether they're names or countries or genders or um, less obvious things, even you can identify those things and mask them, and that will reduce bias in the LLM output.
Correct. Yes. And some of these that do end up leading to bias are actually classified as special categories of sensitive data under the GDPR. And you are not allowed to process them under the GDPR, which is interesting because technically that means that we might not be allowed to process it, even if
Right.
our goal is removing them.
Right.
So that's
Right.
a little bit of a
That's always been a bit of a conundrum.
yeah,
Yeah, yeah.
but we're helping the problem anyway.
Right, right.
um, But things like your political affiliation, religion, sexual orientation, those are all things that are special category data, and you have to be extra careful with those. So it's not uh, just I don't really want to use the word just, but it's not really about only trying to do. Oh, this doesn't sound great. It's not about just ethics. It's also about compliance, and both are very important. Um, but the ethics are being reflected in the law in this case, which is nice.
And on the topics of law and regulation, there are a host of new laws coming online. EU AI Act, things in California and the US are evolving. I, I'm imagining that that's something that you keep an eye on.
Absolutely.
What can you? What's your kind of take on the landscape? And it's probably a whole different hour-long conversation, but like, how are you seeing things evolve?
Mm. Interesting moment in time to ask that question. Mm. So the EU Act, when it comes to ethical AI, it covers things like bias, what is or is not an acceptable use of AI, and it really applies to the higher risk uses of AI. And with regards to sensitive or personal information, that's all covered still under the GDPR, regardless of whether or not the UAI Act applies to you. And one thing that's really nice about regulation, when it's clear, is that it provides guidelines to organizations that are struggling in figuring out what the best practices are. Because they could go look at the regulation or the standard and say, okay, this is what is said is okay. Once we're done this, we can innovate, and there's no limbo. Um, I can't say there's no limbo with the GDPR. There are a few things that can. I don't even know if it's possible to comply with the GDPR at the moment with the technology that's available, and except for more constrained cases. Um, but where part of the world is headed is there's this issue of trust. And this issue of trust is can be grappled with appropriate regulation, with transparency, with making sure the public and the users are aware that their concerns are being taken seriously. And then this other part of the world is currently putting a lot of investments in AI and just dismantled the uh, guardrails, if you will, that were recommended around AI. And that is not going to be particularly helpful with dealing with the huge and growing concerns that the population has around misuse of AI. And that's not good for organizations that are trying to integrate AI into their business either, because now they have to deal with that growing concern without any guardrail to point to that's official. That so leads to inefficiencies down the line.
So then, taking a step back with all of the things that we talked about in mind, like, how do you see the space evolving?
How I see this space evolving is there are certain industries that are ahead of the game when it comes to responsible data practices and have already embedded them within their data practices for over a decade now. And there are other industries that are just catching up when it comes to unstructured data. And I think there's going to be a lot of cross pollination once folks start catching up. What I'm seeing with regards to uh, larger enterprise is that the ones that have already been thinking about AI for a while are now starting to think about the guardrails. The ones who are just starting to integrate AI are not doing necessarily trust, ethics, privacy by design. They're waiting to find out what they're going to be doing with AI first, and then they're thinking about what they're going to be doing with the privacy aspect of things or the ethical aspect of things. And that can be quite problematic because you're not building the pipeline that you need out of the bat. And so that's going to lead to uh, you prototype, and then, oh no, we have to go back and reconstruct everything to be able to get this approved by the board, the chief AI officer, the chief privacy officer, the CISO, whatever. And if you start thinking about it from a this is the problem that I want to solve. What does the pipeline look like that I need to build in order to solve that problem? And then start addressing it from the data aspect of things. That can lead to uh, a bigger lift on the upfront, but down the line, a much more efficient organization because you don't have to constantly just do band-aid solutions to the problems.
Yeah. So data first.
Data first. I think like everybody.
Surprise.
I feel like something at every AI wave we keep forgetting, and we try to ignore it, and we try to pretend that it's not gonna, that we don't need it anymore, but it's not the case.
Yeah.
Mhm.
Awesome. Awesome. Well, Patricia, thanks so much for jumping on and sharing a bit about what you're working on. Very cool and interesting stuff.
Thanks so much, Tim. Real
Thank you.
pleasure talking to you.